Hey guys, welcome to the second lesson on data structures using C++. Today we're going to be talking about array-based lists. Now, more specifically, I'm going to be talking about unsorted lists. I'm not going to get into sorted lists because I just want you guys to understand. That's all we're here to do. If you understand an unsorted list, you'll understand a sorted list. The more important thing to get out of this is this concept of an abstract data type and this whole concept of actually data structures. That's the more important thing to get out of this. So, if you've never really focused on learning data structures and learning how things work behind the scenes with collection types and things like this, you would really have no idea of how they work behind the scenes. Maybe a little bit of an idea, but not really that much, especially coming from languages like C#, where collection types like lists and things like that are used so frequently that you really never have to worry about what's going on behind the scenes. So this whole series of videos is really explaining what's going on behind the scenes in things like C# lists or C++ standard template library vectors, and I forget all the things that C++ has. But the really main point of this all is to understand what's going on behind the scenes. And that by understanding this, it really brings your programming to the next level, because there's lots of things that you probably did not know even existed. So, the first thing I want to do is I want to build an abstract data type, which I'll get to, that implements some kind of, collection, some kind of data structure, some kind of thing in the background that can hold data, but I want it to be implemented using an array-based implementation. And we all know what arrays are. Arrays is a basic data structure that holds data of the same type. So we're going to be using this to build a more complex type. Now, there are other ways of implementing these type of data structure, and that's why I want to really talk about this, because there's other ways. Like in the next video, we'll do it using a linked list implementation. And if you never really focus about this, some of you may not even know what a linked list is. But essentially, a linked list is another way that we can do the same exact thing. And that's where the abstract data type comes in. So, when I say something is an abstract data type, you can logically think of it as something like, to the user, right? To the user only wants to know, okay, how do I insert items into this data structure? Do I call an add function, an insert function, and so on? That's the abstract part to the user. The user only cares about that. But behind the scenes, the user doesn't know what's going on, right? If I had two data structures, let's say I had one that was an array-based implementation, what we're going to do now, and then we have one that's a linked list implementation, and they both had add functions on them, the user only needs to know, okay, for this I call add, and then it adds it to my into my collection. And on my linked list one, if I do add, it adds it to my collection. The user does not want to know what it's actually doing behind the scenes. It's very abstract. We only show the user what they want to know, but the implementation is done behind the scenes. They don't even need to know if it's array-based or if it's linked list-based. They don't need to know that. That's all up to the programmer and what we want to do when we are building it. Now, there are going to be concepts that are going to be hard to understand, because if you just worked with arrays traditionally, you may not have run into these certain things that we'll deal with even in this video behind the scenes, and that you'll find very interesting. And we'll get to that here in a second. So, let's just get started and building our first data structure. So, like I said, our first data structure is going to be some kind of data structure that holds data. Most likely it's going to be integer values, but to the user, we're just going to be calling like add, remove, insert functions. To us, there's going to be a container around it, but to the programmer, which is also us, we're going to be defining the collection and what holds all the data in the back end using an array. That's the first way we're going to do it, using an array. So let's get started. So the first thing I'm going to do is I'm going to create my class, and I'm going to call it unsorted type because I want an unsorted list. So I'm going to go ahead and create this. Let's go new item, header, and I'm going to go unsorted type. Let's go ahead and do that. I'm going to create my class unsorted type. And then, okay, so that's what we're up to. Okay, so inside my unsorted type, we need to decide as the programmers of what do we want to expose to the users. What kind of functions do we want them to be able to use. So there's a bunch that we could do, but we're just going to do a couple of them. So the one function we could use is, let's go ahead and set this up. We can do a make empty function. So this function will be used by the user, and if they call this, it will make our data structure or make our back end, what's holding our data, empty. Apparently, and I want to emphasize, apparently it's empty to the user. So that's one thing that I want to do. Maybe I'll have a function called isFull, and this isFull. We can mark it const also. If this isFull is true, that means that the whatever we're holding, this data structure is full. Now with this specifically, we could have workarounds. We could, since we're using an array based implementation, we could, if we made a dynamic array, we could make it grow so that we wouldn't really run into a problem with that, hypothetically. But I think in this example, we're not going to do that. We're going to use a static array. Maybe we'll do dynamic. I don't know. Who cares? Okay, so that's one. We could have a getLength function, and this getLength function will show how big or how many elements is inside of our collection. We'll have a insert function. So insert item, int item. We're gonna add integers. Delete item, void delete item. Now there's different ways I could make it return the item that's deleted. There's all different things I can do, but I'm just gonna keep it basic. Int item. I guess that's it for now. We could do a retrieve item and things like that, but I just want to keep it basic. So we'll do make empty, isFull, getLength, insert item, and delete item. So this is our public functions. These are what are visible to the users of our data structure. So the users will be able to call these functions, and that's all they have to worry about. They don't have to worry about how this is being implemented behind the scenes. They don't need to know if it's array based or linked list based. They don't need to know that. It doesn't matter to them. All they care about is if they can add, remove, and things like that. Now, depending on what implementation I use, depending if I use an array-based or linked list-based, you'll see that each implementation has its benefits. And sometimes you'll want to use certain benefits over other benefits, or maybe you want to use certain kind of behaviors, like if I want to use a stack or a queue. Each different behavior, each different implementation can return different big O values. So, depending on what the user, pretty much a good way to think of this is having an understanding of all these different things allows us to have more tools in our toolbox. If, depending on what we're trying to make, if something has a better big O runtime of a certain action, I would use that over something else. If it had a worse big O runtime, depending on what I wanted to do. So, depending on those things, that's what really matters. When it comes to building these kind of types. So these are my public functions. Now I need some private functions or private members that are that are really the back end that the users don't have to worry about. So some back end things I'm gonna have, maybe I'll have a length. Yeah, I'm gonna do a static array. So I'll have my array. So I'll have int. I'll say info 100. So our array will start with a 100 slot array. That will be my array. And think that's all we need really. If we need anything else, we can add it later. So we have our public members and our private members. We have our private members, our length, and our array. So our array this time around, our back end that's holding our data is an array. Like I said, it's an array-based implementation, and this is what it means. Our data is going to be held by an array behind the scenes, and we also have this length property that our getLength will use, our isFull will use, our makeEmpty will use. Everything will use this length property, or I mean this length member variable. So what else do we need? Let's also add a constructor. So let's go unsorted type, and we'll use that constructor to set some things up in the beginning. So now that we have all this, let's go ahead and start actually writing the members and writing all this code. So let's go ahead and create this. What did I? So we have this. Let's go ahead and do that. And we'll start with building our constructor first. So inside of our constructor, the only thing we need to do in this certain implementation is set our length to 0. That's all we're going to do in this implementation. We're just going to set length equal to 0. By doing that, our length is all set up now, and we're good to go. Next, let's write the code for our insert item. So let's go ahead and do this. Void unsorted type insert item, and it takes in an int item. So let's write the code for this. So far how we have it set up, we have a length and an info array. So how are we going to put the data into our array properly? Now, the best way to do this is, because we need to think of everything. For example, I forgot to even say, for our constructor in this example, our big O runtime is big O of 1. In this case, because it's big O of 1. It doesn't actually change depending on how many elements we have in the array. We also want to maintain, like, whenever we're building stuff, we always want to try to keep the best runtime as possible. So, and if there's any way we can have a big O runtime of 1 always, obviously that will be the way we want to go. So we want a big O of 1 runtime for this. How do we do it? Using this implementation, it's pretty simple. All we're going to do is we're going to say info, which is our array, sub length. So right now it's 0, so that's the first element, equals the item. But is that all we have to do? So we set the length equal to the item in the array, like this. The last thing we have to do is then just increment the length by 1. By making that go up by 1, that sets it up for the next time around. So the next time we insert an item, info length will be ready and all set up. Because length will be 1, and then it just sets up the item like that. Let's go ahead and make this 10, just so it's easier, because I want to actually draw out some of these things, because it can get a little bit tricky. So I'm gonna start making this picture of what this is gonna look like behind the scenes, and then show how each function is going to affect everything, so that everyone can understand what's going on. Okay, so I just drew out this little diagram, and I wanted to just go over this, and then when we do the next function, then I'll go over it again. So what's happening, let's say hypothetically we have our unsorted type, and let's say we already inserted 3 items. So this is the picture we're getting. So I want to insert another item with you guys so you could see what's going on. So when an item gets inserted, it comes in, and it says, okay, this is our array, it goes info sub length. So that will be this slot. The third slot is length is 3. It goes there and dumps the item in. So let's say the item was 50. Or no, let's just say it's 5. So we dump that 5 into there. Now once we do that, what does the code say? It says then increment length by 1. So then this 3 changes to a 4. And there we have, that's the new picture. So now what you can see when the insert comes in next time, it goes length, which is 4, so it goes to this slot and dumps in the value and increments it. Now, you can see that we'll be running into a problem if this process keeps on happening. You'll see if we got to 9 and we insert it again, the array would go out of bounds and we would have an exception. So inside the insert, we will be doing checks to see if things are full and not. But like I said, this is very basic. If it was a dynamic array, we could just resize it if we were getting too big, and we can make it bigger and then copy everything over. But obviously, that has not the greatest runtime, and you have to think of all those things. But we'll keep it basic for now. So that's the picture that we have right now. So let's go ahead and build. Let's do the I guess we could do. Let's do isFull now. So the isFull function returns if it is full. So let's go ahead and do bool unsorted type isFull. And all for this, all we're going to do is we're just going to return the length equals, and our max is 10. I could make it a variable or whatnot. So if length equals 10, that will return true, saying, oh, okay, that's annoying. Okay, so all this function does is if the length equals 10, that means we're full. So the first thing, let's decide what is the big O runtime of this. And it's 1, because it's pretty obvious. This is big O runtime of 1. And we could, if we want to, we can use this inside of our insert item to do some protection. So right here, we would just say if is full. Oh, we could just say return like that. So that will help protect us now. The next function we could do is, let's go ahead and do make empty now. So let's set it up. Void unsorted type make empty. Now this is tricky. Obviously, well, it's not tricky. It's just weird to think about. Obviously, if I want to keep this big O runtime of 1, how do we do this? If I tell you guys, because you may be thinking, okay, how can I make this empty? Maybe set everything go to 0. I don't know. I don't know what you guys are thinking. But if I said there's a way to do a big O of 1, how would I do it? Looking at this picture, if I could see it like this, how do I make this empty apparently to the user? Because remember, it doesn't matter what happens behind the scenes. All that matters is that to the user, it's empty. And the way we are going to do this is simply going length equals 0, just like our constructor does. By doing this, this actually makes it empty to the user. And this is one of the leaps that we have to take as programmers. You have to understand that behind the scenes, it doesn't matter what happens. All that matters is if it's empty to the user, then it's empty. Now, we're going to be running into things like this all the time when we're learning data structure, so it's important to be able to make these leaps from a basic programmer to an experienced programmer. This is what's happening. Now, in our picture, how does this work? If I call make empty right now, all it does is says length equals 0. So now my length goes to 0. That's all it does. But that's all it needs to do, because to the user, when they do an insert statement now, because our array is going to stay like this. It still contains these 4 elements. But when the user makes an insert, now it says, okay, go to the first slot because of length and dump in the value. Let's say it was 100. Now that 100 is just dumped right into the first slot. Even though, and then it also increments this to 1. even though there is still 3 more items really in the array. So this array has these 3 items, and even though there are really junk in all these other arrays, but there's these 3 other values in this array, even though those are there, the user does not know that, and the user does not have to know that. So, if I were to insert again, it would go, okay, slot 1, maybe I'll insert the value 2, that gets removed, this goes to 2. So those are still there, but as it goes in, it just replaces it and it overwrites the value that was already stored in it with the new value that we're passing in. So make empty is really, it's making it empty. It's just setting the length back to 0. So that's something that made it come to a surprise from some people, that you may be thinking, okay, do I have to make them all equal to 0 first? And no, you don't have to do this. There's really no point to doing that, because it's okay if the values are still there behind the scenes. We'll just overwrite it when we do another insert statement. So that's what's happening right there. So these are our functions so far. Right now, we seem to have the big O of 1 runtime for all our functions, which is pretty good. Okay, so another interesting function that I think some of you guys may like is this delete item function. Now, this delete item function is interesting. And the reason why it's interesting is because there's a couple things we have to do inside delete item. We need to, one, find the item that wants to be deleted. Once we find it, what do we do with the slot then? Do we make it 0? But if we make it 0, then that's kind of going to mess up with everything. What do we do? What is the most efficient thing to do to delete this item? Because think about it. If I want to delete it and then fill that slot up, what do? One thing I could do is delete it and then shift everything in the array. So for example, let's say I wanted to, where's my eraser? Eraser size. That erases that? What? Okay, whatever. I'll just do this. I'll leave those little dashes in. Whatever. Who cares? Okay, let's say I wanted to delete this 400 value. Let's say that was in right now. I wanted to delete 400. So I would first search the array using a loop. So when I say loop, you should be thinking already, oh, we're going to have a big O of N runtime. So I'm going to search it. I want to find the 400 because I want to delete 400. Once I find the 400, okay, I found it. What do I do with it? So I can just, one way I could do it is to just shift the 34 over to here and then the 5 over to there. I could do that and that would fix the problem. But that's a waste of time, and that's a waste. Like, there's no reason to do that. Because that's a lot of... What if I had 1,000,000 items in my array? I had to shift 1,000,000 items. That's bad. So one way I could do this is simply... only because this is unsorted. If this was sorted, then I would have the problem still. Because this is unsorted, it doesn't matter what order everything is in. So one way I could do it is simply... If I want to delete 400, just take 5, take the last element, and dump that into the slot, and overwrite it. So that's all I have to do. Think about it logically. Logically, I did that. I took the 5, I made it into the 400. So now 5 is here, and the 5 is still there, but it doesn't matter. It can be there because what I'm going to do is I'll make the length go down by 1. And you'll see how that works. So that's what I'm going to be doing behind the scenes. So let's go ahead and program this. Void unsorted type delete item int item. So like I said, the first thing I want to do is find the item. So let's set up a for loop for int I equals 0 as long as I is less than 10. That's our size. We could make a variable if we wanted to. I++ if info sub I equals item, then we found our item. So we found our item. Now, obviously, if there's duplicates, there's more problems. Obviously, this is the most basic example. So in this code, we found our item right here. So now once we find our item, what do we do? So we want to pretty much delete this. Now I could set it equal to 0, and there's no point. I could shift everything over, so I could take all the things to the right of this and shift it over all one slot. That would delete it, but I don't want to do that either. An easier way to do it is just to take the last element and just store that into there. And I don't have to set the last element to 0. There's no point to set the last element to 0 because I want to be making the length go down by 1. Because the length go down by 1, the last slot logically is not even there. It's physically there, but logically it's not there, so I don't have to make it equal to 0. I could if I wanted to, but there's no point. So what I'm going to do is I'm going to simply say info sub I equals info sub length. Actually, info sub length minus 1. The reason why I'm doing length minus 1 is because when I insert an item, it makes length go up by 1 to prepare for the next one. So I need to do length minus 1 to get the actual last element. So length minus 1. So this is actually doing the deletion right here. I'm setting the value that I want to delete equal to the info of the last element. Is there anything else? There's also get length, but who cares about that? So we have the basic types for this example. Let's go ahead and start setting up the code for this. Oh, actually, before I do that, I'll do 2 more functions. Actually, the big O runtime of this is big O of n, pretty basic because we're doing the loop. So the amount, actually, this is big O of n. Yeah, it is, okay. And the reason why this is kind of iffy-ish. The reason why it's big O of n is because depending on how big the array is, the more comparisons we have to do. Although I am hard coding this 10 in, which kind of makes this iffy, I would still consider it big O of n because in reality, this is just for teaching purposes. In reality, I would have a variable that was the max length and it would be probably dynamic. And because it's dynamic, this would be a variable and it would change depending on the size of it. But I'm just hard coding the 10 in just for teaching purposes. So let's just say it's big O of n. Because we see the loop. That's a good indication. So yeah, this is our deletion. It finds the item and then switches the item with the last. So this is a deletion. The last function I want to just make, just for the fun of it, is the show function. And this will just show all the items in it, in our data structure. So let's just go ahead. Void unsorted type show. And this is going to be, obviously, this is going to be big O of n again. And this is going to be the same for int I. Let me just copy that. But this time I'm going to. Let's go ahead and see out info sub I. So that's our show function. So now we have all this. This is pretty much our abstract data type, our data structure, whatever you want to call it, our collection type. Let's start using it. So let's go ahead and create unsorted type, unsorted type. So we have our unsorted type. Let's start messing with it. Let's go unsorted type dot insert item 5. We'll do a few 6, 7, and 8. And then let's just go ahead and do a show. ust.show for the fun of it. Oh, wow. Wait a second, I just thought of something. For the show function, I did not even think. There's going to be a problem with the show function. Can anyone figure it out? Quickly pause and figure out what is the problem with the show function that I just made a mistake with. Let's go ahead and run and see what happens. I don't think the user would want this kind of output. Ready? 5, 6, 7, 8. trash, 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 trash. We don't want that. So the user, now the user is seeing how big the array is and things like that. No, the user only inserted 4 items. That's all he gets. We made a mistake, and the reason is we need to change this to length. My mistake. Sorry for that. So now it will only go to how many items we have in the data structure. So let's run it now. Now we see the correct data. We see the 5, 6, 7, and 8. So we inserted 5, 6, 7, and 8, so the user only sees 5, 6, 7, and 8. Let's go ahead and mess with it some more. UST, what else can we do? Let's go ahead and do delete item. So let's delete item 7. Let's delete item 6. So if we delete item 6, what is going to be the output? Because it's unsorted. Think about this logically. We added 5, 6, 7, and 8. We programmed that it goes and finds 6. Then it could have shifted and made 7 and 8 and shifted that upwards, but it doesn't do that. Instead, what it does is it takes 8 and copies that in there and then makes length go down by 1. Let's go ahead and run this now. So we should see 5, 8, 7. Hopefully I'm correct. And look at that. We have a mistake. So we see the 5, 8, 7, but obviously we forgot to make the length go down by 1 in our delete item because we are not smart. So let's go ahead and I guess we could do it in... I'll just do it here. No, let's do it here. Obviously, I was not thinking properly, but now you guys will not make this mistake. So let's run it now. Now we should see 5, 8, 7. 5, 8, 7. Now the reason why we still got that output, which is interesting, is because I didn't make the length go down. And let me comment that back out actually and run it again. The reason why we got this output 5, 8, 7, 8 is because all we told it to do for the deletion is to simply delete it. I'm just copying the last element into that one. But we didn't actually set the last one to 0 or anything. We just make the length go down by 1. So making the length go down by 1, we get the image of that we get the image that it's gone. Like the user thinks it's gone, but in reality it's still there. To the user, we deleted the 6 that they wanted to, but we just simply replaced it with the last element. But it deleted it. That's the most efficient way to do it. So that's all we need to worry about with that. So that's that. What else can we do? We did an insert. We did a delete. Let's see. We have get length. That's simple. Is full. It's simple. Make empty. Let's call make empty. We did insert, delete, make empty, show. What happens? Nothing happens. We don't get any output. What if I go ahead and do an insert after the make empty? Does it still work? Does it pick up where it left off? Let's insert 100 and let's see. As you can see, the 100 is there. So everything seems to be working fine. We built a data structure that internally is built off of an array. Its internals are an array-based implementation. And we talked about big O of n, big O of 1, how it works with this. We talk about what's the difference, like what are the most efficient ways to delete things, what are the most efficient ways to do things like this. So that's how we did all that kind of stuff. And then we demonstrated how it works. So for the most part, this is the basics of an unsorted array-based implementation. This is pretty basic. So that's it, I think, for this video. The next one's going to be on an unsorted linked list implementation. And let me just check. I'm not missing anything. I mean, this is the pretty basics. If you could understand this, you're off to a good start in learning and following these videos. Really, you're off to a good start. Yeah, so that's it for this video. Thanks for watching.